Now, we each inherit 50% of our DNA from our mother and 50% from our father. We're in a museum, so I expect you all to get this right. If your mother's yellow and your father's blue, what color are you going to be? Very good. Very good. And I used to have circles and squares, and then I thought I'd get sophisticated with girls and boys. So ladies, we're green, and all the guys, you're green, because we have half of our DNA from each parent. But we each have this yellow dot, if you will, that we inherited from our mother that didn't mix with anything from our father. And that's called mitochondrial DNA. So it's not really it's not on your it's not your X chromosome per se, but it's something like the X that you got from your mother that doesn't mix with your father. And so you have the yellow dot, your mother has it, she got it from her mother, she got it from her mother, and it gives us an informative look at your maternal line, the history of your maternal line. Now, it's not really a yellow dot, okay? Dr. Day, I know it's not a yellow dot, but just for illustrative purposes, so don't go back tomorrow and tell people they have yellow mitochondrial DNA. I don't know what color it is. So ladies, let's focus on us for a minute. So we have the yellow dot. Our brothers and sisters have the same yellow dot because we have the same mother. We got it from our mother. She and her brothers and sisters got it from our grandmother. She got it from her mother, and so on. As women, we pass it on to our sons and daughters. And our daughters will pass it on to their children. Our sons will not, okay? Because our sons are not women, they're not mothers. Are you with me? Okay, so let's look at the guys. I'm not gonna leave you out. You have the yellow dot. Your brother and sister have the same yellow dot, which you got from your mother. Your aunts and uncles got it from your grandmother, and so on. Your sister will pass on your yellow dot because she's a mother, but you and your brother won't. Okay? You guys got that? All right. So if you look at my yellow dot that I got from my mother Cynthia, who got it from her mother Margaret, who got it from her mother Margaret, and so on. So when we look at that history of that yellow dot, it tells us something about all these women and their descendants. This is what mitochondrial DNA looks like in an illustrative form, and our mitochondrial DNA is where the energy in our cells is found. So it's really the workhorse of our body as I understand it. It produces the energy that makes our bodies work. Now, this is what it looks like in letter form. It's a series of chemicals, adenine, cytosine, thymine, and guanine. You guys have seen CSI and Law and Order. You've probably seen these letters going across the screen at some point. I don't have those kind of graphic skills. But this is what it looks like. And can you all see this? It's a swab. It's like a long Q-tip. And what happens is this is an easy way to collect DNA. So you rub the inside of your cheek, inside, to collect the DNA. Doesn't hurt, right, ladies? Dr. Wilson, Dr. Taylor and Lori Wilson. It doesn't. She'll be a doctor one day, maybe. It doesn't hurt. You collect the DNA yourself with this. Some companies use a little. It looks like a little brush on the end. Some companies use. You take a solution and swoosh it around in your mouth and spit it back in. You can really get DNA from anything. Your hair, your nails, your chewing gum, the glass you leave at the restaurant, whatever it is. But you just collect the DNA with this, and then we send this to the lab, and the lab clips the tip of the DNA of the swab off and puts it into a solution to extract the DNA. And then they get the DNA and they what they call amplify it. They make millions and millions of copies so that they can read it. And then they turn that sequence into the series of letters that the scientists can then use most easily to determine whatever it is they're looking for about you. Now, we have about each one of these letters represents a chemical pair. And we have about 3 billion of these pairs in every cell of our body. 3 billion. When we're looking at your mitochondrial DNA, we're only looking at 400. So it's not enough to tell us and you know now, your eye color and all that stuff about you is not on the mitochondrial DNA. So what we're looking at is an area of the DNA that's only informative for ancestry. Now, Dr. Kittles, he spent about 12 years collaborating with researchers on the continent of Africa, collecting some data himself, and incorporating data that's already in the public domain to get lineages or sequences, if you will, from over 25,000 indigenous Africans from across the continent. And these black dots represent populations that were sampled in our database. And what I want you to notice about this map is that we have the majority of our samples from West and Central Africa. Why? Because that's where Africans in the Americas were taken from, in large part. While we do have some from the north and the east and the south, this is really where we came from. And so he worked with anthropologists and linguists and archaeologists to make sure that he was capturing I shouldn't use that word, not capturing, but that he had the populations that were that had contributed to the slave trade. If I showed you this map and the majority of our samples were from up here, then you should all just kind of get up and walk out, because when we compare your DNA to DNA up here, we're not going to find any matches, really, because that's not where we're from.